Let's take a look at the questions on homework number 19. We'll start first with solving equations involving distribution. When we solve equations, we always start with the same steps. Over here on the right, you can see distribute, combine, then we move on to the inverses, adding or subtracting, multiplying or dividing. When we distribute, we multiply the coefficient outside by each of the items inside the parentheses. This will give us 5x minus 10. The rest of the sentence remains the same, so we rewrite it as is. After we distribute, we check to see if we have like terms on the same side of the equal sign. So I cannot combine anything that goes across the equal sign like that. That's not allowed. But I can combine items that are on the same side, like these two variable terms. 5x, and that says plus 3x. So 5x plus 3x makes 8x. And now I have two more like terms, and look at them carefully. It says minus 10 and minus 4. So if I was to type this in my calculator, I could only have these 4 characters. You cannot have another minus sign in here. So be careful, because I see students doing that sometimes. Because there's nothing in front of this 10, this has to be the negative button. But because an operation must be typed, this has to be the subtraction button. So be careful that you understand the difference between when you use the negative and when you use the subtraction sign. Negative 10, subtract 4, will give us a minus 14 on our calculator, so that's what we write. The equals and the negative 38 remains the same. Now that we're done combining, we can move on to the adding or subtracting step. The opposite of subtraction of 14 is addition of 14. We rewrite. And now our final step. We're going to divide by our coefficient and get our final answer, which is negative 3. Type it in this response box, and you're all set. Let's try one more. Okay, this time we're going to multiply 3 times negative 5x, which is negative 15, and 3 times positive 4, which is positive 12. Everything else, we rewrite the same. Again, I have multiple like terms, so I'm going to combine my coefficients, right? The coefficients of my variables. That's negative 15 plus 5. Type that in your calculator. Negative 15 plus 5. It will give you a negative 10. Don't forget to write the x. Our next step is positive 12, subtraction 1. And we put those together, we're going to get plus 11. Now we're ready to add or subtract. Rewrite, and now we're ready to divide. Use your calculator to do this math, to compute so that you get the correct signs and values. The answer is 5. Okay, I think you're starting to get the hang of how you do this. I'll do one more only because this has a negative coefficient out in the front, and I want to make sure that you are aware that signs can change when you are distributing. So here we go. Remember that our steps here are distribute first, combine second, then we move to adding and subtracting. So here we go. Negative 5 times 5x is negative 25x. Negative 5 times positive 3 is negative 15. Now, if this had been a negative 3, we'd get a positive 15, right? So watch your signs. Everything else we rewrite. Combining like terms, type in your calculator, negative 25, subtraction 5. Negative 25, subtraction 5. Then type in your calculator, negative 15, addition 1. Negative 15 plus 1. So we've distributed, we've combined. Now we're going to move on to the addition or subtraction steps. Use your calculator to assist you. Now we're dividing. Use your calculator to get the right sign. X is equal to 1. Alright, we're going to move on to the second topic now, which is two-step equations with fractional coefficients. So the idea here is that you are to understand that when you go to clear your coefficient, if the coefficient is a fraction, then you multiply by the reciprocal. So again, there's no distributing, there's no combining, because these are unlike terms. So we're going to go straight to the addition or subtraction stage. Now the opposite of multiplying is dividing, but we don't divide by fractions. We don't do that. So instead of dividing by a fraction, we multiply by the flip. That's called the reciprocal. We take that fraction and we flip it over. Take out your calculator, type 3 times 24. And get your answer. All right, let's try this one more time. So in order to solve for b in this situation, we are going to remove our 19 first. That's our constant. We're going to rewrite. And then we're going to multiply by the reciprocal. We're going to flip this over. Get your calculator out. Type 42 times 12 over 7, which is going to give me a 6. 6 times 12 is 72. That's just a coincidence that those answers are the same as the last time. All right, I think you're getting the hang of it. Let's take a look at the third one, which is an old topic for us. We're going to determine if this graph is a function. So what we're going to use is our vertical line test, right? We're going to take a vertical line and we're going to drag it down our graph, right? We're going to, take a vertical line and we're going to drag it down our graph. And we're going to look to see if we ever touch the graph in more than one place. And if we do, then we have a repeating x value. And if we don't, like this graph, then we have a function, right? It passes the vertical line test. Let's do that one more time. So imagine you're drawing a vertical line down your graph. And if you ever touch your graph in more than one location, like here, you fail the vertical line test and you are not a function. So use your vertical line test to help you scan these functions. This one fails the vertical line test, so it is not a function. This one fails the vertical line test because right here, I touch both of them at the same time. I touch more than one. Actually, I only touch one point though. I don't touch, oh here, I fail the vertical line test here. I fail the vertical line test here. So this is not a function. This is not a function. All right, let's go to the next topic. Determine if a set of points is a function. So when you have a set of points and they're asking you if it's a function, you're focusing only on the x coordinates. And if you repeat an x coordinate, you are not a function. So look only at these x coordinates. If you repeat one, you are not a function. But if you have all x's unique, no repeats, then you are a function. So for us, the last one has no repeating x values with different y values. Scan down your list, look only at your x values, read the question, make sure you're being asked if it is a function. So 9, negative 6, 1, and 1, that has a repeat? No. 9, negative 7, 6, 4, this has no repeats, that's a function. Sometimes they'll ask you if it is not a function, so make sure that you're reading the question carefully. All right, now we're going back to transformations. And you need to be able to identify what type of transformation has occurred. So let me shrink this down a bit for a second here. Which transformation would take the figure A, which is pink, onto figure B, which is blue? Okay, so I'm just going to pick a single point here. That is the point -3, 7. And I map it to this point, right? That is a reflection, and it becomes +3, 7. So you notice that these values, these actual number values, they are the same. That cannot happen with a translation. Translation changes your numbers. That cannot happen with a dilation. Dilations change your numbers. With a rotation, your numbers would swap positions, and that didn't happen. So I know that since these values 3, 3, 7, 7 are the same, that this is a reflection. The fact that the values changed one of the signs, right? You started as a -3, 7, and you became a +3, 7, that this x coordinate changed. And the only way for an x coordinate change is for you to reflect over the y-axis. So we are looking for a reflection, and we are looking for it to be over the y-axis. And I can confirm that with my points, my coordinate points if I need to. All right, which transformation would take A to B, from A to B? So again, I'm going to try and find one of these values here. So here to here, I could say that this is rotating. So I had a -2, -4. I became a +2, +4. So that can happen with two reflections, or it can happen with a single 180-degree rotation. So let's take a look at what our options are. A reflection over the line y equals -x. Nope. A counterclockwise rotation of 180 degrees. Yes. All right, next one. Which transformation would take figure A, the pink one, to figure B? Well, when you look at this, you can see that the orientation is changing, so it's not a translation. It is turning. If I look at this point here, it originally was 3, 6, and now the new point is 6, -3. So this is definitely a 90-degree turn, because these numbers have swapped places. And not only have they swapped places, but which direction you turn, counterclockwise or clockwise, will determine which one changes its sign. So because this one had a sign change, it must be a 90 degrees clockwise rotation. So a clockwise rotation of 90 degrees. You can see it turning, boop, 90 degrees clockwise. All right, let's take a look at this question here. We have a clockwise rotation. We have a reflection over y equals -x, a reflection over y equals +x, or 180 degrees. Let's talk about those reflection lines. Reflection line over y equals -x would be, would be this straight line like this. Okay. And if I reflected this over, it would be looking more like that. That's a reflection over. So we know it definitely is not a reflection over the line y equals -x. Now how about the line y equals +x would be a line that goes like this. And it's definitely not reflecting over that line, because it would reflect over itself and it would look like that. So we're definitely looking at a rotation, and our options are clockwise 270 or clockwise 180. So let's take a look. Clockwise 270, make 1, 2, 3 turns. It would need to be over here somewhere. And clockwise 180 is 2 turns. 1, 2, so that definitely puts it in this quadrant. So even without looking at the points, I can use my common sense about these types of transformations to know that this is 180 degrees. Let's try one last one. All right, this looks like a perfect flip, okay, but it's going from pink to blue. Right, it's going from pink to blue. That's a perfect reflection. So we're going to say that's a reflection, and make sure you choose the right axis. We're going over the y-axis. Right, you may need to go back in your notes and look up those rules to kind of really help you with these transformations. Okay, let's take a look here. Next one is dilations. So the figure below is dilated by a factor of 3. So all I need to do is jot down each of these ordered pairs. So this ordered pair right here, Q, was 2, 2. And if I multiply those both by 3, I'm going to get 6, 6. 6, 6 will be my new point. Right? So Q was 2, 2. And now it will be 6, 6, because I multiplied it by 3. Now my next one is 1, 2, 3 boxes over, so that's going to be 6 boxes over. So negative 1, this point right here, negative 1, 2, when I multiply that by 3, I get negative 3, 6. So negative 3, 6. There we go. And now I have to do n. N is negative 2, 0. So when I multiply that by 3, I get negative 6, and 3 times 0 is 0. So negative 6, 0. Now I got to do my next one here. 0, negative 3. Again, I'm writing down the original point right here, O. Original point is 0, negative 3. And if I times these both by 3, I'm going to get 0, negative 9. 0, negative 9. So I'm going to click here to start my segment and go down to 0, negative 9. Now my last point is 3, 0. So that's going to be 9, 0. I'm going to click once here to make my segment, and then I'm going to close these two segments together. There we go. So I took these coordinates and I multiplied each of their numbers by 3. Let's try this one more time. Dilated by a factor of 4. So here's my first point. 1, 2. 1, 2. 1, 2. When I multiply that by 4, I'm going to get 4, 8. So this point here, letter E, is going to become 4, 8. Now I'm going to do letter F. Negative 1, 1 is negative 4, 4. Negative 4, 4. Negative 4, 4. Now I need G. Negative 2, 1. That's going to be times 4. Negative 8, 4. There we go. Connect these. And now my next point is C. 2, negative 2. So that's going to be 8, negative 8. 2 times 4 is 8. Negative 2 is negative 8. So 8, negative 8. I'm going to connect it back here. And now my last point, 2, 0, is going to be 8, 0. Connect that here. And then connect this back to the top. Click Submit. Okay, that's how you dilate. Alright, last two. Triangles. Hopefully you remember the rule for triangles, and that is that all three angles inside of a triangle must always add up to 180 degrees. They always add up to 180 degrees. And 85, what was it, plus 58 equals 180. I accidentally wrote an equal sign in here when I went to write. Plus, e plus 5 is 13, 13, 14, equals 180. Subtract 143, subtract 143. This marker is not working. And we're going to get 37 degrees. 37 degrees. Alright, I think you're getting the hang of this. Next time I'll copy it and put it in my smart notebook. Again, same rule. Add up all three of these measures. let's go here. So all I need to do is add x plus 41 plus 58 equals 180. Combine like terms. 99. Oh, I keep doing that. This is a plus side. 81. So we type that in, and we're all set. Should feel pretty confident with this skill here. Let's take a look at the last item, which is the triangle inequality theorem. The rule about triangles is that two sides always have to add up to a number that's higher than the third side. These two items have to always add up to more than the third side. So if you were asked which of the following could not represent the three sides of a triangle, then you're looking for two numbers here that are not greater than the longest third side. So we're looking for two numbers that do not add up to that third side. So 15, right here, 15 plus 29 is more than 42. Because 15 plus 29 is 44. On this question here, 10 plus 18 is 28. So yes, that is longer than 25. Over here we have 13 and 25. And that adds up to 38. That's longer. But 13 and 18 only makes 31, which is not greater than 31. It's exactly 31. And so that means it's not a triangle. So what we're going to do here is we're going to select this fourth choice because that one is not larger than the third number. Second question, the same as the first. Which one does not represent the three sides of a triangle? 5 plus 14 makes 19, so that's bigger. 15 plus 27 is 27 plus 15 is 42. So this one is not large enough. Okay, last one. Which one could not represent the three sides? So this one is 9 plus 13, that's 22. This one, 4 plus 9 is 13. 13 is not larger than 14. Let's see what the next problem is. Always they're asking us, always not. I wonder if there's one where they'll ask us which one is. That's it for homework number 19.